In this instance, what we've got is effectively arsenic, elemental arsenic, reacts with NaOH, and that forms, as you can see, it forms Na₃AsO₃, which is sodium orthoarsenite. And we've been asked to work out the volume that's occupied by the hydrogen that's produced, right? So hydrogen is also produced, and we've been told the mass of the elemental arsenic that actually reacts in this particular reaction, right? So we've been given that information. So how are we going to go about working out the H2 produced? One of the things we have been told is that the NaOH here, as you can see, is an excess, right? And what does that mean? Well, what that means is the limiting reagent in this reaction is going to be the arsenic, effectively, effectively it means we can use this value to work out what the amount of hydrogen, how much hydrogen is produced, because it's going to be based on the mass of arsenic available, right? Okay, so to work out the actual volume occupied by the hydrogen, we need the number of moles of the hydrogen, right? So this is going to be our first objective. Let's work out the number of moles of the hydrogen. But we don't have, we can use the balance equation to work this out. So what we can first do is work out the number of moles of the arsenic, right? And so the equation we can use to work this out would be that the mass is equal to the number of moles multiplied by the molar mass, right? And we simply rearrange this, and by dividing both sides by the molar mass to get the equation that the number of moles is equal to the mass divided by the molar mass, right? So we have the mass, right? So that's going to be equal to, I'm going to make this specific. So effectively, let's focus it, because this is specifically the number of moles of a specific species. So the number of moles of arsenic, right, is going to be equal to, and it's going to be 10.88, which is the mass, right, divided by the molar mass. So the molar mass, we're going to need to get that from the periodic table. So if we do refer to the periodic table over here, you can see arsenic is here, and that's got a relative atomic mass of 74.9, right? So the molar mass of the arsenic, in this case, it's very simple. There's not actually, we don't really need to use a calculator. It's just going to be the relative atomic mass. It's just going to be 74.9, and if you wanted to write a number there, you could write times 1, but it's the same thing, right? So 74.9 grams per mole, right? So that's the units for molar mass. Okay, so we can now use that value, right? So 74.9 and so if you do have a go at working out what value you're going to get from that, I'm going to make sure I round it, but that's going to give you 0.1452603. okay, so this part's just rounded. Okay, so that's going to be in moles. And when we look at the balance equation, we kind of need to use this to work out, because now we've got the number of moles of the arsenic, but we need to work out the number of moles of the molecular hydrogen, right? So H2, how many moles of H2? And if you look at the equation, what this effectively tells us is that, so I'm going to set this up as a ratio. So it's the number of moles of arsenic compared to the number of moles of H2, right? What the question tells us is that for every 2 moles of arsenic, right? So for every 2 moles of arsenic, we're going to have 3 moles of H2, right? And if we now try and get the left hand side to 0, I mean not to 0, to 1, so divide both sides by 2 effectively. To do that, we're going to get 1, and that's in the ratio to 3/2, right? And so for every 1 mole of arsenic, the moles of hydrogen is going to be 3/2, right? Which is basically 1.5, right? So the number of moles of H2 is equal to 1.5 multiplied by the number of moles of AS. This is basically what this tells us. And we have the number of moles of AS, right? We just worked that out. So therefore, the number of moles of H2 is 1.5 multiplied by 0.1452603, right? So if you do work that out, you're going to get the number of moles of the hydrogen, molecules, and so that's going to give you 0.2178905, right? And that's going to be in moles. All right. And well, at this stage, we're going to actually need to look at, well, what do we do with this information? We need to work out the volume, right? Our focus beyond the moles is the volume. Now, what the question tells us is that for every given mole of a gas at room temperature and pressure specifically, it's going to occupy a volume of 24 decimeters cubed. Now, in the context of this, what does that mean? Well, it basically, with what moles we have, if we multiply that value by 24, it's going to tell us the volume occupied effectively, right? So therefore, the volume of H2, which is what the question is asking us to work out, is going to be 24 multiplied by our molar value, which is 0.2178905, okay? And if you do have a go at working that out, what you should find is that you get 5.229372, okay? And that's going to be in decimeters cubed, right? And the question makes it specific. The specific request in the question is that the answer should be given to a maximum of 2 decimal places, right? So as you can see here, maximum of 2 decimal places, right? So because of that, what we're going to need to do is effectively say that is going to be 5.2. If we round this, we need to round this up. It's going to be 2 pre, right? Decimeters cubed to 2 decimal places. Okay, so in this case, this would be our volume of H2 that's produced in this reaction.